When asked about the inventor of the light bulb, most people instinctively think of Thomas Edison. However, the history of artificial illumination stretches back much further than Edison's time, with various forms of light bulbs emerging decades before his famous invention. In fact, the true origins of the light bulb can be traced back to a phenomenon known as barometric light, discovered centuries before electricity was fully understood. The accidental discovery of barometric light. The story of barometric light begins in the late 1670s with an unexpected observation by French astronomer Jean-Félix Picard. While working with a barometer in a dimly lit room, Picard noticed something extraordinary. The mercury inside the instrument was glowing. This mysterious luminescence, occurring as the mercury sloshed around in the glass tube, would come to be known as barometric light. Picard's discovery quickly caught the attention of the scientific community. The renowned mathematician Johann Bernoulli took particular interest, conducting his own experiments by spinning vials of mercury to produce the eerie glow. At the time, scientists theorized that some unknown substance within the mercury was responsible for emitting light when agitated. Early investigations and theories. Despite initial excitement, the scientific establishment's interest in barometric light waned relatively quickly. The late 17th and early 18th centuries were a time of significant scientific advancement, with figures like Isaac Newton revolutionizing our understanding of physics. In this context, the mysterious glow of mercury was overshadowed by what seemed to be more pressing scientific pursuits. However, the phenomenon wasn't entirely forgotten. In 1705, Francis Hawksby, an assistant to Isaac Newton, decided to investigate barometric light further. Hawksby's approach was innovative. Instead of manually shaking mercury vials, he designed a more sophisticated apparatus. Hawksby's electric globe. Hawksby's device consisted of a 9-inch glass sphere connected to a hand crank. By evacuating the air from the sphere and introducing a small amount of mercury, Hawksby could produce a sustained glow by spinning the sphere with the crank. This contraption, in essence, became one of the earliest forms of a hand-powered light bulb. Hawksby's experiments yielded several intriguing observations. Touching the spinning sphere increased the brightness of the glow. The spinning sphere exhibited properties of electrical attraction, causing small objects like thread and brass to stick to its surface. These findings led Hawksby to support the prevailing theory that some special substance was being released from the mercury, causing both the glow and the electrical attraction. Polignare's alternative approach. Across the English Channel, French physicist Pierre Polignaire was also investigating barometric light, albeit with a different methodology. Polignaire used simple glass tubes containing mercury, which he manipulated in various ways. He discovered that simply slapping the tube could produce the glow, eliminating the need for spinning. By adding sand to the tube, he observed that the glow stopped in areas where the sand settled on the inside of the glass. These observations led Polignaire to a different conclusion. He proposed that the motion itself, rather than a mysterious substance, was responsible for generating the light. Understanding barometric light. The role of frictional electricity. With the benefit of modern scientific knowledge, we now understand that both Hawksby and Polignaire were partially correct in their interpretations. The key to barometric light lies in a phenomenon known as frictional electricity, more commonly referred to as static electricity. The mechanism of frictional electricity. Frictional electricity occurs when certain materials rub against each other, causing a transfer of electrons. This process creates an electrical imbalance, converting kinetic energy into electric potential energy. In the case of barometric light, as mercury moves inside the glass container, it rubs against the surface, transferring electrons to the glass. This electron transfer makes the glass negatively charged and the mercury positively charged, creating an electric potential. The positively charged mercury is attracted to the negatively charged glass due to the opposite charges. When the container is moved, some of the positively charged mercury separates from the glass. Electrons from the glass leap to the mercury to recombine with the positive charges. This recombination releases the electric potential energy in the form of light, the barometric light observed by Picard and others. Interestingly, this process is fundamentally similar to the mechanism behind lightning, where charges reconnect along a path between clouds and the ground, releasing light and energy on a much larger scale. Explaining Hawksby's observations. The understanding of frictional electricity also explains why Hawksby's act of rubbing the sphere enhanced the glow. The friction from his hand provided additional electron transfer, generating more potential energy. This increased potential energy ultimately converted to a brighter light. The electrically charged glass surface attracted small objects, demonstrating the electrical attraction Hawksby observed. The legacy of barometric light. Hawksby's experiments with barometric light are considered a pivotal moment in the history of electricity. Although the concept of electrons wouldn't be discovered for nearly 2 centuries, his investigations provided crucial insights into how objects become electrically charged. Impact on electrical science. The study of barometric light laid the groundwork for several important developments in electrical science. It inspired the creation of some of the earliest electrical components. It contributed to the understanding of electrostatic phenomena. It demonstrated a practical application of converting mechanical energy into light energy. A new perspective on light bulbs. In many ways, Hawksby's glowing spheres can be considered the first true light bulbs. They quite literally contained lightning in a bottle, harnessing electrical phenomena to produce light in a controlled manner. This perspective adds a fascinating dimension to the history of artificial lighting, predating the more familiar incandescent bulbs by nearly 2 centuries. The evolution of artificial light. While barometric light represents an early milestone in the history of artificial illumination, the journey to modern light bulbs involved numerous innovations and inventors. Humphrey Davy's arc lamp, 1802, created using 2 charcoal electrodes connected to a battery. Warren de la Rue's platinum filament bulb, 1840, an early attempt at incandescent lighting. Joseph Swan's carbonized paper filament bulb, 1860, a significant step towards practical incandescent lighting. Thomas Edison's carbonized bamboo filament bulb, 1879, often credited as the first commercially successful incandescent light bulb. Each of these inventions built upon the knowledge and technologies that came before, including the insights gained from the study of barometric light. Conclusion: redefining the light bulb's origins. The story of barometric light challenges our conventional understanding of the light bulb's invention. It reminds us that scientific progress often occurs through a series of incremental discoveries and innovations, rather than singular moments of invention. From Picard's accidental observation to Hawksby's experiments and beyond, the phenomenon of barometric light played a crucial role in advancing our understanding of electricity and illumination. It serves as a testament to the importance of curiosity-driven research and the often unexpected paths that lead to technological breakthroughs. As we reflect on this history, we gain a deeper appreciation for the complexity and richness of scientific discovery. The next time someone asks, "Who invented the light bulb?" perhaps the most accurate answer isn't a single name, but rather a story. A story that begins with a mysterious glow in a mercury-filled tube and spans centuries of human ingenuity and exploration. In the end, the history of the light bulb, like many scientific advances, is not a straight line from darkness to light, but a winding path illuminated by the curiosity and perseverance of countless individuals across generations.